Hi everybody. Good afternoon. Sorry, I'm a few minutes late here. But nonetheless, we shall start. And I think I need to exit from one of these connections here just in case. All right. Uh, so a reminder that we have class tomorrow at 18 hours. Yeah. You know the drill. We're trying to catch up. Also, another reminder that the assignment, the checkpoint, I want to call it a checkpoint, tagged as business understanding, had its associated deadline extended. I'm not sure if people picked up on this. I think an email was sent through. It was mostly due to the fact that due to the glitch in the spreadsheet, there were a number of groups rather, that decided to choose the same topic. So 2 topics were affected, and so what we did was we deleted, to be fair, right? Because I know what was going to happen if we said, well, the first group to claim the topic is going to keep that topic here. That's not really the kind of way we wanted to open here. So what we did was we excluded all of those 2 topics that had multiple groups associated with them, and then we had those affected groups. Yeah, I don't know about that. We had the affected groups. We had the affected groups sort of like choose, and I thought I was sharing this thing here, but we had the affected groups choose new topics. Okay, so there was that, right? And I'm referring to this. So you notice that the assignment number 5, which is tagged as a business understanding checkpoint, where you're supposed to finalize everything to do with business understanding. We shall check the last commit message and also the last save point associated with the Jupyter notebook that you're using, right, as you're working on this project, as a basis to see what exactly has been done. So this deadline is tomorrow, 23:59. Yes, we know tomorrow is Saturday, but the deadline is 23:59. And also, what we have done is we've pushed the deadline for assignment number 6, which was supposed to be today, but we pushed it to the 18th. So it's due Monday. Okay. I hope you've taken note of these things. The other important assignment, announcement, I suppose, is the fact that on Thursday next week, which is the 21st, we have another lab, right? An in-class quiz, if you will. Anyways, so today we are going to transition to our discussion of lecture series number 4. If you remember, we had hinted on multiple occasions, actually, that some of the things that we were discussing as part of those 6 phases of the CRISP-DM methodology were going to be covered in depth. Okay, our focus in lecture series number 3 really was just to understand your typical data mining pipeline, but of course, for us to be able to understand some of those things, we had to gloss over certain specific operations as they relate to, preprocessing and transformation, really, which is the reason why we found ourselves briefly talking about things like the bag of words model, right? And what actually it is we do when we are converting text into numbers, or what sort of text pre-processing operations do we perform, like case forwarding and stuff. We didn't really go into detail. So the idea behind lecture series number 4 is for us to have a firm sense of those things. And in fact, it's during our discussion of lecture series number 4 that we shall find ourselves, for instance, appreciating the role of so-called natural language processing libraries like GenSim, like NLTK, packages or libraries like Spacey as well. Although I think we shall restrict our discussion to NLTK. So we introduce you to these things, and then also we'll have a very gentle introduction to the scikit-learn package, sklearn. You saw it in action a couple of times, I think, especially when we were vectorizing text, right? Using the bag of words model. You know how we were essentially just looking at our corpus, and using that corpus, we extract a subset of all unique words from that particular corpus, right? And we use that as a basis to create this vector, which then we use to essentially slot in associated frequencies as they relate to the document we are processing at that point in time. But so we'll have a very gentle introduction, scikit-learn, and I guess this will be useful because our very next discussion is going to be centered around understanding how we build things like classifiers, right? Models initially, model implementation. So there's that, right? So the journey starts now. You know, when I was thinking about how exactly I don't know assemble the lecture series, I sat there and I was thinking, you know, this is like it's a very difficult thing to do here. I think for me, really, part of the reason why it's difficult is because I don't know what you've covered and what you haven't covered, right? So there's always this thin line that one has to navigate very carefully here. I don't know. Have you had a dedicated statistics course, for instance? I know you have different. Yeah.
No, we haven't.
Okay. Yeah. That's okay. Yeah. So I sat there and I figured maybe the very first thing we need to do, you know, before we get started is to really understand these different attributes types, right? These different attribute types. So maybe just have a brief discussion of sources of data or something. We know this, but you know, talk about it nonetheless. And then, you know, have a discussion centered around different attribute types. And then afterwards, we shall look at part 2, tagging this as data preprocessing. I think it's important that we try and understand the sources of errors, right? How it is we find ourselves in a situation where we have missing values and all those things. Anyway, and then we will, I mean, I know a lot of the things we're going to do as part of, you know, preprocessing / screening techniques are going to be more or less like a repeat of what we did, but my thinking is we're glossing over most of the things. And so the goal of this lecture series is to go through some of those operations in great detail. You know, like for instance, how we go about handling, you know, this issue to do with missing values. And incidentally, most of the things that we're going to be looking at, especially as it relates to part 2 and part 3, are probably going to be looked at in depth in the companion notebook. So I'll spend a lot of time walking us through the notebook or notebooks that I'm going to put together. I probably will start going through these notebooks tomorrow, actually, when we have class at 18 hours. So anyway, so there's that. So in terms of part 1 here, I thought it would be nice to remind ourselves, right, of the fact that I mean, my reference here is a reference point to the CRISP-DM methodology, by the way, and I think I mentioned this. If you remember our discussion of the CRISP-DM methodology, we realized that the things that we're discussing in this lecture series, which is data preprocessing and transformation, actually linked to stage number 3 or phase number 3. To put it more aptly here, it's phase number 3 of the CRISP-DM methodology. And we realized that this phase actually is perhaps the most time-consuming phase, if you remember. I don't know how many of you remember this graph here, for instance, right? This, right? Now, the most time-consuming phase. Hopefully, this is making sense now after we are done with the an outline of the CRISP-DM methodology, right? You know, so we realize that it's the most critical because the data that we are feeding to the model is going to ultimately influence the efficacy or the effectiveness of the models we are implementing, the inference models, right? So we need to clean up the data and we need to transform it because the estimators or the algorithms that we end up using expect numbers as input, right? So quite a number of things that we're doing. So we're transitioning into this time-consuming phase. And a reminder again that in terms of the specific operations that we're supposed to perform in this phase, right? We discussed these generic tasks, if you remember, right? The CRISP DM methodology or approach comprises of phases. Each phase has associated generic tasks, the things we're looking at. Each of these generic tasks has associated specialized tasks, and each specialized task has associated so-called process instances, right? So in terms of the generic tasks associated with data preparation, this is it, data selection process, for instance, preprocessing, transformation and derivation, things like integration and merging of data and dataset description. So what we're doing in essence is spending a great deal of time discussing these things here, right? Again, this graph, I love this graph. Although I guess with the rise of the machines, the so-called large language models, we can probably do a lot of smart things now, such that the amount of time we're spending here is really it's not going to be as much as it used to be before we started making use of a lot of these base models, right? Llama and all those things, right? Quen and all those things. But anyway, so there's that as well. Now, again, I want to remind you that part of what we are trying to do here is to get us to a stage where when we have access to messy data, I'm going to call this messy data like this, and I'm calling it messy data, I'm calling it messy data because it is messy, right? If you look at the text that is in the red bounding box here, you notice a lot of very strange things here, like the word 1941, right at the bottom there, right? I have no idea what that is here. What is it? I don't know. Well, 1941 actually is probably the total number of words, actually, tokens, words, when you use space as a separator. But look at things like m.eng, for instance, right? May not really be useful, maybe useful, maybe not. But look at this, punctuation marks, right? These double backslashes, for instance, probably not useful for us, right? Or probably not useful for specific use cases, right? Where you're processing this text. And so what we do as part of data preparation and data preprocessing and preparation is we come from a stage where we have messy data like this. Well, messy data can actually be useful, by the way, to you and I, is it, as human beings. The way we are structuring text matters, right? If text is in all uppercase, there could be some meaning, some reason why it's in all uppercase. This percentage symbol has a meaning to us, to you and I. A comma has meaning to you and I. A full stop. These things here in parentheses like 1, 2, this has meaning. But when you're feeding this to a machine, an intelligent machine, this is useless to it in most instances. Okay? The fact that Xamarin is in all uppercase means something to you and I, but the machine doesn't care, right? At least this is how they are designed, really. So the goal is to get from this stage, which is stage number 1, to stage number 2, where you clean up the data, right? We briefly introduce things like case forwarding. So you notice in here, the very first token, or the word thesis, right, is in all uppercase, right? And then after thesis, you have m.eng, for instance, and then equals abstract, and hyphen, and then Xamarin. Well, in stage number 2, we notice that the word thesis has been altered somehow. We've applied case forwarding, so it's in all lowercase, and we've reduced the text, right? So instead of thesis, we have thesis. We're applying really basic stemming here, right? We're just removing the suffix, ideally. And we know this is actually what we are doing, because if we start trawling through this text, for instance, we will notice that we will come across words like sustaining, right? Just after internet here, There's sustaining in here. Sustaining such a service is. In here we have sustain, which is stemmed, including service is stemmed. In fact, this is weird here. Sustaining service. Even however is stemmed. Wow. Right? So we're kind of like applying these processing operations here. And then at some point, the goal is to say we want this to be converted into a form that the algorithms that we are using are expecting, right? Because they will not process, they will not work if we feed them this. In fact, you get an error or something, right? So they'll only be able to work if you provide as input this. So in other words, this is the equivalent of this, right? So this is what we are essentially doing. And by the way, we are kind of like simplifying matters here, because this is not the only way we can leverage so-called transformation, right? Text transformation. There's a whole range of other techniques we can use, like for instance, TF-IDF. And in fact, we're going to focus our attention on term frequencies, or the bag of words model, and so-called term frequency inverse document frequency model, right? Where the number, you'll soon see, is quite interesting actually. In this particular case, we're doing a simple counting, yeah, where we check if a word exists in the document. So it's like in document, in this particular document here, does the word abstract exist? If it does, then you put a 1, or you count how many times. If it doesn't, it's a 0. Now, by the way, this example, I think is a good thing I use this, because it illustrates the other thing that we glossed over, but I mentioned it, the fact that in most of these NLP use cases, real-world use cases, you do not process text in such a way that you view these tokens as single entities, right? You typically compound them, because in as much as you're dealing with the machines, but there becomes certain instances where you'd want to look at words when they're combined with other words, right? So I'm talking about n-grams here, right? You can notice here, after the ellipses here, you have Zambia nation, you have Zambia there, Zambia object, Zambia study, Zambia, I don't know, the Zambia youth, Zambia. So what in essence, the way we were converting this stuff here into words, into numbers, is such that we were taking into account bigrams, right? So in other words, our vector it's constructed in such a way that you look at all of these words first, right, as individual entities, and then because you're playing around with bigrams, after you string together, or after you create a vector which comprises of columns corresponding to these single words here separated by a comma, right? So I have TC, ENG, abstract, Xamarin, Zambian. Then you start combining these words, right? Like you look at words, 2 words that follow each other, in other words. So you combine TC and engineering and consider that to be like a column or something. And then you come to ENG and abstract, and then abstract Xamarin, right? This is why you have this thing, Zambian nation or something. And I don't know if this Zambian nation is something there. You can't really see Xamarin, Zambian NREN. Do we have Zambian NREN? Zambia preliminary and stuff, right? So bigrams. This has implications on the size, by the way, of your vector. And in fact, typically, from my experience, most of the use cases, when we're working with text, what works best are so-called trigrams, right? Not bigrams, because if you're working with your bigrams and you say, if you're working with bigrams and you have something like I am a final year undergraduate student at the University of Zambia. In essence, when you're working with unigrams, like you're treating these things as single entities, you're going to have a vector that will just have I it will have I am like this. It will have I am. I don't know about this. It will have I am a final A or up to Zambia. If you're working with diagrams, once you have these single entities, then you're going to have I and M like that, and then M A like that. Of course, you'd remove. I know what you're thinking. Well, but you said these are stopwords. It's just an example, and then a final. At some point, you notice that if you look at the University of Zambia, you will have something like the university, right? The university, and then you'll have something like University of I don't know what's happening here, but there's a bit of there's somebody who has microphone activated. I don't know who that is. I'll switch it off now. Not yet. Okay. Who is it? I'm trying to find out who it is, right? I don't know if it's Taonga or something like that. We can just have them mute themselves. Mr. Onga, do you want to mute yourself? I don't understand this. The problem is if I configure this thing to mute you, when I ask you to ask questions again, it's going to be a problem, right? You can do that, but at fourth here, I don't understand. So University of, and then you have of Zambia, right? And you notice that if you were think of it from this perspective, right? If you're looking at using this as a way of extracting named entities, for instance, in this particular case, University of Zambia is a named entity, right? But when you're using diagrams, you won't be able to pick it out. So using trigrams means you're going to be looking at words that follow each other, 3 of them. So it'll be like I am a will be considered another, will be considered separately. A final year undergrad, undergrad student, right? Until you get to a stage where you have the University of. Now, some of these things may not really make sense, by the way, but you have something like the University of, and then the University of, and then you would be able to pick University of Zambia, something like that. If that kind of like makes sense. Anyway, so there's that, right? Right now, another thing to appreciate here is that typically when you are working on a data mining project, is usually the case that you find yourself working with a diverse set of data sources. Again, the data set that we have been using as an example here was already merged, right? But I've hinted at the fact that data comes from a self-administered questionnaire, for instance, SIS, spreadsheets compiled by this course lecturer called Lighton or something like that, right? I don't know where else it comes from, the data here, but yeah, so Moodle logs as well, and because of that, it turns out that many a times the data that we are collecting may have a lot of anomalies, right? It's usually not very clean. I'll give you an example of the spreadsheets that Lighton prepares, right? Many a times you'll find that in the spreadsheets, maybe there could be inconsistencies in the way that, and I'm going to show you these spreadsheets, maybe it's for you to make sense. It could be inconsistencies in the way that the data is, I don't know where this is here. Inconsistencies in the way that the data, the spreadsheets in this particular case are created. I hope I have these things in my data set. I have the whole data set somewhere here, right? But sometimes it's not even here. There could be inconsistencies in the way that the data is created, right? Maybe it could be that in a previous year, Lighton did not, I don't know, showcase to you some example data sets here, right? Not here, I guess, but I don't know if this is not here. This is that's okay. It's not here. There could be inconsistencies in the way that these data sets have been created or something like that. Wow, this is weird. I thought I had this information. I normally have this information, but then again, I think for older years or something, I may not have. That's okay. I may not have done this, but I know I have them somewhere here. I guess I can open them. Just gonna close this, list it. It's gonna open up some spreadsheets so you see what I'm talking about, right? If we are to compare, I don't know if it's here. I guess I don't know. No, I've changed the way I organize things these days. I don't know why. I guess it has something to do with sometimes when you're getting old like that, you tend to organize these things differently. I don't know why this is not seemingly working here, but I also know where else I have those raw data sets, not exactly in the actual folders where I'm organizing these things, but maybe in the research folder or something like that. I should be able to find that there, I guess. And I think it's in 2023 where I have the entire data set. I think it's here or something. I don't know. I was meticulously keeping these things here, but I can use this as an example. Doesn't matter. I see I don't have the raw data sets or something, but at least I wanted to showcase the actual the actual quiz scores and all those things, right? But these are all merged. These are all merged data sets. At least as they relate to the things that I create myself, right? These are all merged data sets, sadly. Maybe in the last thing that I taught, I may have everything, I guess. I don't know. Nope, not yet. Yeah, it's insane what's happening here. I know what. Anyway, but that's fine. I just wanted to. I wanted to showcase the fact that the original source of data may be messy, right? In fact, this also applies to information from SIS, for instance, right? Just because information has been extracted from SIS doesn't necessarily mean that that information is going to be accurate, right? There may be anomalies, for instance, or Moodle logs, right? So what I've just opened is like a raw data set from SIS. This, so it's showing me for each student, for instance, I have a sense of what sort of courses they enrolled into in first year or something. And then for Moodle logs, I have something like this, right? The key thing here is that these data sources may be messy like that. And because they're messy, you need to clean up this information, right? Anyways, again, this is what I was saying, right? The data set we're using integrates information or data coming in from multiple sources, SIS, LMS, the self-administered survey as well. Now it turns out that, by the way, this is a motivation for why cleaning is important, preprocessing is important, right? Because when you're combining information from different sources, usually you end up with anomalies being introduced into this one merged data set. So the idea then becomes that prior to the merging, you clean up the data coming in from all these different data sources, and then you harmonize these different data sources so that the merging is slightly easier here. Okay, so multiple data sources. And then in terms of data representation, right, we begin to realize that we typically end up dealing with different types of data attributes first. That's an important point to stress here. However, it turns out that irrespective of the original type of format, typically the data that you are handling or the attributes associated with the data that you are handling need to be converted into some structured numerical format, right? For the machine learning algorithms. And really the standard representation is typically in a tabular format where you have like attribute value pairs, for instance. Your rows will represent like individual observations or objects, instances. And then the columns will comprise of characteristics or things or features that would describe that particular object or observation, right? In addition, each particular cell, right, in this table will represent a specific value associated with attribute. In essence, what we're talking about here is our pandas data frame, right? Something like this here. Yeah, so fundamental challenge we're saying is that the machine learning algorithms we end up using need to understand numbers, not concepts, right? Converting everything we know about an object, for instance, into some structured representation, a table. Right? Now, it turns out that there are different sort of attributes that we work with. And we've seen this in the data set. A nice way of understanding attributes is to latch on to your statistics, but I know you guys haven't done statistics, but I'm sure you know a thing or two about statistics, right? In statistics, it turns out the type of attribute is important. They've told you this, in part because the attribute type is going to influence the type of statistical test you're going to have to perform. Even though you haven't done statistics, I'm sure you've read up and you've heard of things like one sample t-test, right? When you're hunting for those p-values, we performed a one sample t-test on our data set, or a one sample median test, for instance, or a binomial test. Or a lot of people like throwing fancy things around. We did an ANOVA test or a chi-square goodness or fit test or something like this. All of those tests, it turns out, are identified. Like if you have a data set, you pretty much identify the type of test you're going to perform, in part by determining the attribute associated with the thing that you are measuring, the dependent variable, and the things that you are adjusting to check if they're going to influence the dependent variable, the independent variables, right? Incidentally, some other factor that influences the type of statistical test, for instance, would be the distribution of the data, right? So you use one test if your data is normally distributed, and a completely different test if it's not normally distributed. So if it's non-normal, for instance, versus it being normal, right? Anyways, back to our discussion of data mining, it turns out that similar to statistics, the type of data attribute influences the technique that we use to transform the data. So in other words, what we are saying is that when we want to transform numbers, perhaps through scaling here, we can leverage scaling on numbers. However, we can't do that on categorical attributes, right? If we have categorical attributes, we can take advantage of one-hot encoding. Whereas when you are dealing with numeric data types, we use a completely different technique. So key thing here is that there are different types of data attributes, and each of these different data attributes will involve the use of different transformation techniques, ideally. Incidentally, one would argue that just like we have different types of attributes, the type of preprocessing operations will in part depend on the attributes that we're working with, for instance. You're not going to come here and tell me that the attribute gender, for instance, we're going to apply case forwarding. You understand what I mean? It's like you come here and you say, why did I call this? You're not going to come here and say, well, we have the field gender, and for us to preprocess gender, part of what we're going to do is we're going to case forward. No, right? Case forwarding is reserved for textual content, for instance. You understand, if this makes sense? what makes sense for us to what makes sense for us here in terms of preprocessing is we do this pandas.pd.get dummies or something like that, right? So we transform like that. Anyways, so transformation technique defines that here. Yeah, so different sort of attributes. And in case you are wondering, well, is there a limit as to what sort of different types of attributes we will find ourselves working with, or types of data we'll find ourselves working with? Well, and that's what I'm thinking about the range of input data you're going to be working with is think of how you use your computer, like your phone, for instance. And you did this in computer architecture, right? Computer systems and architecture. They'll tell you that a computer functions in such a way that you provide it with input, right? It processes the input and then it provides, the CPU does the processing, and then you have your output or something, right? This is why you discuss your peripherals. And if you look at your input devices, the range of things that you're providing to these input devices is restricted, is it? Audio, images, text to the keyboard or something like that. Anyway, now it turns out that this input and output data involving machine learning algorithms obviously is typically represented in mathematical way. We'll discuss this at length. I'm just trying to give context in terms of how these so-called data attributes fit into the bigger picture here, in case you're wondering. So these input and output data involving machine learning algorithms need to be represented in mathematical way, right? Using attributes. So typically what we do when we are building these inference models is we are trying to fit, right? We're trying to fit data into some equation, some mathematical equation. So something as simple as f is equal to fx, for instance. And the thinking here is, or maybe something as simple as y rather is equal to fx, or more apt to put is y hat because you're predicting is equal to fx. And the thinking there is that you can build this model, or you can learn a model which can then generate new y hats using new input data or something like that. And typically what comprises of this f of x here are the independent variables, right? Yeah, the inputs. Whereas the y hat is the thing that you're predicting. So f of x includes the so-called independent variables, and then the y hat will be a dependent variable, the thing that you're measuring. In our case, if you look at this, we'll be talking about our y hat, or y equal to the final exam, and then most of these other attributes will be the x's, right? So in fact, when you say I'm building this model so that I try and learn, or I'm learning a model so that I come up with something like y is equal to f of x. This x actually, right? This x comprises of, it could comprise of a series of x's. So you have x1, x2, x3, right? All the way up to xn. If you've been following, you begin to notice that in the example we've been using, this simple example, this n can actually be in the hundreds, is it? Because already we see that the useful attributes from here will involve things like sponsor, right? I'm just going to get a few of them here. Involve things like sponsor, gender, and then when it comes to motivation, gender and a few others, but when it comes to motivation, you notice that motivation is a piece of text. Yeah, because motivation is text, if we want to include motivation when we're learning our model, what we'd have to do is we vectorize motivation. And when we vectorize motivation, we realize that vectorizing motivation results in, I'll call this motive, or mot, results in 372 columns, if you remember. Because there are 372, what we are saying is that ultimately our input vector is going to have, in fact, not just gender here, because we're going to we're going to one hot thing called gender. So we'll have gender M, we'll have gender F. At least people ask me, why are you starting with M? Is it because you're male or something? Gender F, we have sponsor again. Sponsor will have we'll have what? Sponsor 75GRZ. We'll have sponsor, I'll call this SP, just SP, so that we don't run out of space. We'll have sponsor 100% GRZ. We'll have sponsor waiver, right? Those that are related members of staff. We have sponsor self, you know? And again, the motivations are like 372 of them. So you have motivation 1, motivation 2, motivation 3. But of course, these are not really like mot 1, mot 2. These are like the actual words comprising our corpus, right? So one of these could be like Zambia. One of them could be UNZA or something like that. One of them could be female or something like that. If this is making sense, I know it is making sense. So anyways, the representation obviously depends on the problem space you're working towards, right? So input data, again, for us to understand these attributes, input data comprises of like those rows, right? Instances. Input data comprises of various instances. These observations, and each instance, each record or each observation is associated with data attributes. Instance 1, instance 2. All of these are associated with the same type of attributes. Like in this particular case, we have attribute student ID, student name, makeup test, final examination. All of these things will hold different values, which when looked at collectively will help us identify this particular observation or instance. Okay? So this is why we're saying the observations attributes collectively help describe the observation. The attributes will help with measurement of an observation. What is your age? How much did you get in quiz number 1? And all those things. Now, attributes, right? The more classical ones can either be categorical, get back to things like text, and images and stuff, but they can either be categorical or continuous. Your so-called categorical attributes, these are qualitative measurements, most in some instances, well, quantitative sometimes anyway, we'll call them qualitative measurements. Yeah, this is a qualitative measurement, although you can perform mathematical operations, like statistical operations, like check if one value is equal to what you're checking for, something like that. But we just say categorical attributes are generally qualitative in nature, and they comprise of specific subtypes, right? So a categorical attribute can be either nominal, ordinal, or dichotomous. I think I should just say it could be dichotomous, nominal, or ordinal or something, because dichotomous attributes are somewhat similar to nominal attributes. You're looking at categories of things. So these categories of things can either be 2 or more categories. You can't say I have a category of things that is exactly 1, right? It's 2 or more categories. I'm going to say it can be exactly 2 categories or more than 2 categories. Now, the thing about the categories is, if you think about it, there are categories that can be ordered and categories that cannot be ordered. So, categories that cannot be ordered and are exactly 2 are what we are calling dichotomous attributes. In the Republic of Zambia, gender, I don't know if it's sex or gender, I don't know. They say gender, sex, something. But gender can hold only 2 values, female or male. Exactly 2. Dichotomous. I wonder. I'm trying to think of something. Education status. Okay, not education status. Yeah. Pass status is dichotomous because either you will pass CSC 5792 or you will fail, right? 2 attributes. I'm not sure if that is a question, but yeah, yes, Nefas, and then we'll go to Benaya. Yeah. Oh, okay. It wasn't, right? Yeah. And then you also have well, categorical attributes here would be things like 1, 2, 3. These are dichotomous something attributes. And then the so-called nominal attributes would be categories which cannot be ordered but are more than 2. So if there are 3 of them, or 4 of them, or 5 of them, or 20 of them, we're calling those nominal attributes. Like for instance, I'm doing software engineering. Somebody told me last time, those of us doing network engineering, right? I'm doing, I don't know if it's I don't know what else is systems engineering apparently. If there's more here, these are categories, right? We cannot order this, right? It's not like we saying software engineering is better than networking engineering or systems engineering. These are all the same as far as we are concerned, right? They're the same. Well, we can leave that argument also in case you're like, you're doing software engineering, you're like, no, software engineering is better than network engineering. But they're all the same because we cannot order these. These are nominal attributes, right? The other simple examples here, like it could be like wealth status, for instance, is there. I don't know. I like using these examples. If you haven't yet looked at this, please do the Zambia demographic household survey. Zambia demographic household survey. Wow. List 2034 survey. I only have the NDC survey. Maybe there's something here. The Zambia demographic household survey is quite nice here, but the NDC survey, right? Let's look at. I like using this here because most, it's always this country of ours is like, what do they call this? It's been normalized here to just abuse alcohol or something, especially people your age or something. So if you say we wanted to look at the results, we're analyzing this data and we're looking at results of, there we go, alcohol consumption, right? These age ranges here. Well, maybe it would depend on there's no, if we're looking at how data is being analyzed here, like alcohol consumption by age, these age ranges here are classic examples of nominal attributes, right? There's no, related to this problem, we are not saying that the age group 18 to 29 is more important than the 60 to 69 age range. No, these are just categories, right? It's a way of organizing information. You understand? Or if we said, this is a good one. If we said we wanted to look at results from the perspective of residents, right? Rural versus urban. I don't know why they don't have peri-urban here. This is dichotomous, but if we had peri-urban, it would be nominal. It's quite nice. It's unfortunate that they only have age ranges here. This is a very nice report, by the way. You should probably look it up. I don't know if you care about this. It's crazy like that. Even tobacco smoke. But we're not discussing that. So there's these different types of attributes, right? And then there's also continuous attributes, and we'll talk more about categorical attributes, including examples here. Continuous attributes here, quantitative. Okay, so they can either be interval attributes, for instance, or they can be ratio attributes, right? And I'll give examples for all of these things here just now. I don't know why we don't have this thing is mixed apart. I'm going to change the slides here. Might as well just start with your categorical attributes, right? Again, what's important is for you to kind of appreciate the the things, operations that you can perform on these so-called dichotomous attributes or categorical attributes, right? So for dichotomous attributes, you're looking at just two categories only, and you'd have like a discrete set of values, right? Only one value can be held at a time. So you can't say I have a gender attribute and it has a value F and male. No. Okay. And the categories obviously are mutually exclusive. The only numerical operation, if you think about it, the only numerical operation you can perform here is in a quality test, right? So the only thing you can do here is check is the gender, is this equal to F, right? Is it equal to F, for instance? Nothing else. You can't say, I'm going to say gender is greater than 0, something like that, or less than 0. It's just a quality test. You're checking, right? For equality. That's it. And then when you remember nominal attributes, you're dealing with more than 2 categories. Again, it's a discrete set of values, right? Only one value can be held at a time. Categories are mutually exclusive. And again, the only numerical operation you can perform here is the quality test. Now, what you begin to notice is that, technically speaking, a dichotomous attribute is a nominal attribute. However, the nominal attribute is not going to be a dichotomous attribute. What's happening? Somebody's saying there's a test. What test are you talking about here? Okay, I want to pause here. Somebody just sent a thing of a test, but I won't cut this. So you have a test at 1303. Wow. We're going to, because you sent this at 13 hours, which is now. We can leave it at that. For those who have a test, we'll see you when you see us, which is tomorrow. We have class at 18. But I'm going to stick around for those that perhaps may have any sort of question about this discussion. We're just easing our way into this. Most of this is pretty straightforward. Those of you that are preparing your reports, maybe you'll be required to do some statistical analysis or something. Now you know that when you're using R or SPSS to do a quantitative statistical test here, the type of attribute matters or something like that. Are there any questions about this so far? If not, thank you very much. A reminder that there's a milestone that is due tomorrow by 23:59. Hudson and myself will be checking at the times and stuff. But why do we have classes every day? We don't have class every day. I don't remember us having class on Tuesday. I don't think we're going to have class on Sunday here. We don't have class every day here. The answer is, but why do we have this thing? Because we have a plan, right? You know, if you miss the first class, you know that it's recorded. Just go and see if you can play back the first class here. We are having class here. We are having class today because it's on the timetable. We had class yesterday because it's on the timetable. Okay. We had class on Tuesday because it's on the timetable. We did not have class on Wednesday. We did not have class on, we had class on Sunday because we were supposed to have a makeup class on Saturday and we didn't. If that makes sense. Yes, there's a hand up. Okay, no hand up. Very strange here that goodbye. See you tomorrow at 18 hours. We don't have class. If you want, we can have class on Sunday as well. Bye.